under the radical sign. And to solve these equations, we have to isolate the radical expression and raise both sides of the equation to an appropriate power to get rid of the radical. And then we can just solve the resulting equation. So here's what I mean. For example, when I have rad x plus 2 equal 4, to get, this is, the radical expression is already on one side of the equation and everything else is on the other side, so we don't need to do anything. Here I have to raise both sides to the second power. So if I square both sides, here the second power and the radical sign would cancel each other, so I would get x plus 2 and 4 squared is 16. And then I have to isolate x, so minus 2 minus 2, I would get x equal 14. So this is my answer, but there's something I need to emphasize here, that when we have square roots, we have to always check the answer, because sometimes we get answers that don't work in the original solution, and we call them extraneous solutions. So let's see if that actually works. So I want to see that x plus 2 equal 4 is really true or not. So I plug in this 14 here. I would get 14 plus 2 under the radical equal 4. And then 14 plus 2 is 16 equal 4. And this is absolutely true. So our answer is x equal 14. Here I have 8 plus rad 5x plus 6 equal 12. So I want to find the solution to this equation. I want to find x. So first of all, I would have to isolate the radical. So subtract the 8 from both sides. I would get 5x plus 6 under the radical. This is 6 and 5. 12 minus 8 is 4. And then I have to square both sides. So these two would cancel each other, so I would have 5x plus 6 equals 16. Minus 6 minus 6. 5x equals 10. And then x equals 2. So let's check to see if our answer is correct. 8 plus rad 5 times 2 plus 6 equal to 12. Let's see if that's right. So I have 8 plus 5 times 2 is 10. 10 plus 6 is 16. Rad 16. And then rad 16 is a perfect square, so it's 4 plus 4. 8 plus 4 is 12, so this is absolutely true, and our answer is x equals 2. Here I have another example. If we do everything right, we don't have to check the answer. We should be getting the right answer, but it's always good to practice. So let's just check that. It's 3 plus cube root of 4 times 5 plus 7 equals 6. plus cube root of 4 times 5 is 20. 20 plus 7 is 27. Let's see. So 27 is a perfect cube, so cube root of 27 is 3. And 3 plus 3 is 6, so this is absolutely true, and our answer is x equals 5. Alright, here I have an example for you to try, so go ahead and pause the video and try to do this. We'll go over it together. Alright, I have 4 minus cube root of 11x minus 6 equal 1. So I'm trying to isolate the radical. So there's a 4 here, there's a positive 4 here. I would subtract 4 from both sides. So minus 4, I would get negative cube root of 11x minus 6. And that's 1 minus 4, so it's negative 3. And then I'm going to multiply both sides by a negative 1 so that I get rid of these negatives. So this is actually like this. Times negative 1. And then I would have cube root of 11x minus 6 equal 3. And then to get rid of this radical sign, I would cube both sides. So to the third power, to the third power. So these two would cancel each other right now, and I would have 11x minus 6 equal 27. And then I'm going to subtract add a 6 to both sides. Let's move to here. (27 plus 6 is 33). So our answer is 3. Again, we don't have to check because it's a cube root, but let's just practice. So it's 4 minus cube root of 11 times 3 minus 6. Let's see if that works. So 11 times 3 is 33, minus 6 is 27. 27 is a perfect cube, so it's 3, so it's 4 minus 3, and this is absolutely true, so our answer is right, x equals 3. In some examples, you have more than one of the same variable, like this example here. I have 20 minus n equal n. Let's square both sides to get rid of the radical. So if I square both sides, the second power and the square root would cancel each other, so I would have 20 minus n equal n squared, and then let's just move everything to the other side. So plus n, I would have 20 on this side and n squared plus n on the other side. And then let's subtract the 20 from both sides. So I would have n squared plus n minus 20 equals 0. And this is a quadratic equation. Let's factor it out. This is 5 and 4. So n plus 5, because here is a positive, and n minus 4. So if n plus 5 is 0, so n would be 5, negative 5. And then if n minus 4 is 0, then our n is 4. So we have two answers. Let's check if they're both right or not. So for n equal negative 5, we would have square root of 20 minus negative 5 equal 5, and that is 20 minus negative 5 would be plus 5, so 20 plus 5 would be 25, and that is 5, and So rad 25 is 5. And then for n equal negative positive 4. We would have the square root of 20 minus 4 equal 4. 20 minus 4 is 16. So 16, rad 16 equal 4. And rad 16 is a perfect square, so rad 16 is 4, and this is absolutely true. So both of our answers work.